go fast forward with understanding, but that is nothing but VA0 and VA0. So basically, the pole voltage of an inverter decides the limit of the inverter. That means, in general, if you go for a study of inverters, as we go advanced controlled converter, advanced inverters, where the controllers play a vital role. In the advanced inverter, the inverters are specifically decided with the number of levels. More the number of the levels of an inverter, we say some characteristics or parameters of the inverter is improved. What are such parameters? If you take a basic inverter circuit, in the case of inverter, what happens? We have the pole voltage, where the pole voltage decides the level of an inverter. In the present case, if you see how many levels are there, in this operation, when we consider VA, VOA, and VOP, we have the level of V minus plus V by 2 and minus V by 2. So, number of the levels that we observe in the pole voltage basically decides the level of the inverter. So, in this present case, if we say what is a pole voltage, it is VA0, wherein we can find two levels in the inverter, we call it as two-level inverter. But what is the nature of the inverter? Is a single phase. Now let us go for full bridge inverter. So it's a full bridge inverter. There are some other specific aspects also which we need to understand. What are the main role of the diodes that are connected across the switches? For suppose if it is a resistive load, there is when the cycle of transition is changing from S1 S4 to S2 and S4, as you are seeing on the screen. So if it is S1 and S4 and if it is S2 and S3, you observe the nature of the current, if it is not R load, will exceed or will raise exponentially to the peak when the voltage is at the peak, and all of a sudden when the transition happens, switching, the current doesn't directly fall to zero because the nature of the load doesn't allow the current to fall to zero immediately when you change the direction of the switching. So ultimately what happens? It again steeply down, come to zero, and then. So during this period, as you are switching off the S1 and S4, so the conduction of this falling current going to the negative during the positive direction is conducted by the D2 because the current flows in this direction during the first half cycle, and in the negative half cycle, when this S3, S1 and S4 are turned off, the same current direction flow, but it is through D2 and D3 in this direction. This specific point is very important to note because we say, that means now if we say it's an inductive load, between the point 0 to T by 2, your voltage is positive direction and your current is also in positive direction. But if you see at T by 2, the current is, the voltage is going to minus T by 2, whereas your current is going down to 0 and then it is going to the negative. So at this specific point, you have the voltage is negative, but your current is in the positive direction. That means during this specific period, what is happening? The energy of the power that is stored in the energy stored in the load is transmitting back to the source. This is the basic concept. So that power reversal is enabled by the diodes which are connected across the switches. And that's why those diodes are called as feedback diodes. It's important to know the pole voltage as well as the operation of feedback diodes to understand that how the inverter can also be used for the rectification process. Because when we talk about rectification, it is nothing but conversion from AC to DC. When we talk about inverters, it is from DC to AC. But even when we operate the inverter, in the inverter mode of operation, it is very important to note that even the power is from the inverter is bidirectional power flow. So the power goes from source to load, and in some instant, we can also make the power to flow from load side to rectifier. Basically, this specific small minor nature of the inverter, it can be used for the characterizing of power flow from DC side to AC side when you connect the renewable energy source, where the digital controllers play a vital role. Because DC side to AC side, it doesn't happen because now what happens in the present scenario, if you see the diodes D2 and D3, because of their nature and characteristics, they are enabling the power flow in the opposite direction. But when we want to make the same mechanism for a long time, wherein if the DC side if you have some active source, and let us say in the AC side you have an active source, and in the DC side if you have the passive load. So by using the controllers, you should be able to control that specific instant such that the power flow can be fed from AC side to DC side, even though you use the inverter. That's not how we go to the further steps. But understand that. But why pole voltage is essential is, as you go in a conventional way of deciding the level of inverter, most of the studies just count the number of levels that are observed at the output side and they decide this is the level of an inverter. But generally the level of an inverter should be decided by pole voltage, because when the pole voltage is symmetric in nature, it means all the switches in the inverter or the converter is going to having a same peak inverse voltage. Now, why we are specifically deciding about peak inverse voltage? For suppose, in the present concept, if the voltage of the DC is V, as you see on the screen, and now then only one switch is turned on at any point of time, why? If both the switches are turned on, it will lead to short circuit. So when one switch is turned on and another switch is turned off, what was the voltage that falls across the switch? It will be the total VDC, right? So when we are connecting or using an inverter for a specific application which is operated at a specific voltage, it's not something like I use some voltage and I am getting some output voltage. The components or the power electronics content which you are using in the inverter should be able to sustain for the voltage level. Because in theoretical, you just say that I give voltage of 100, I give voltage of 1000, I give voltage of 2000 something. But in practical, it is not possible because every component will have a voltage sustainability range, which we call as a rating. So, when this voltage, if you keep on increasing, there will be some level of voltage where your switch could not tolerate the maximum peak inverse voltage and the voltage that switch will damage. So, when we go for practical applications, it is very important that a conventional inverter can also be used only to a specific level only. You cannot go beyond a specific level. If you want to go for a specific level voltage beyond something, this is not sufficient, no doubt in that. So that's why when we go for household UPS system or inverter systems, we use a normal inverter because our household voltage is around 230 volts. So if the switch is able to tolerate 1000 volts of peak inverse voltage, our regular DC or the battery voltage is able to get it operated. So the peak inverse voltage is the other factor which actually decide for the design of a inverter or a converter for an application of renewable energy. Now coming to the three phase. What happens if you go for a three phase? Simple. So let us say in the three phase system,